Welcome back to our ongoing deep dive into the OEIS, the online encyclopedia of integer sequences.
Yeah.
You know, we love uncovering the fascinating stories behind these numerical patterns.
Absolutely.
And today,
You tackle
we're
it.
tackling A00000075. It might seem like a simple string of numbers at first glance,
Yeah.
but trust me, this one's got some hidden depths, especially when we connect it to the world of quadratic forms.
What's so captivating about A00000005 is that it gives us a glimpse into this mathematical concept that really underpins so many fields.
Okay.
We might not see it every day,
Yeah.
but quadratic forms are really working behind the scenes in areas you might not even expect.
Okay, let's unpack that before we get to the why.
Right.
Can you remind us what A00000007 actually is? I'm guessing not everyone has this sequence memorized.
Fair enough. In essence, this sequence counts how many whole numbers less than or equal to 2 raised to the power of n
Okay.
can be expressed as 2x start plus 3y bara, where x and y are integers.
All right, so there's a formula at play here.
Right.
Could you walk us through an example to make that a bit more concrete
Absolutely.
for our listeners?
Let's take the example provided in the OEIS entry for n3.
Okay.
The sequence gives us the value 4 to understand why we start by calculating 2 to the power of 3,
Oh.
which is 8.
Right.
Then we need to find all the whole numbers less than or equal to 8 that fit our equation.
Right.
2xs plus 3y and a.
Right.
And it turns out there are exactly 4. 2, 3, 5, and 8.
Okay.
You can find combinations of integers for x and y that when plugged into the equation will give you these 4 numbers.
So it's like a numerical puzzle trying to fit the pieces together. But you mentioned this goes beyond just playing with numbers.
Exactly.
This is where quadratic forms come in.
Precisely.
You might be wondering why this specific way of representing numbers is important.
Right.
Well, it turns out it's a gateway to this powerful concept.
At 000075 gives us a concrete example of how we can represent numbers using a specific quadratic form, which in this case is 2x Santos plus 3y Otol. And quadratic forms themselves are these expressions with squared terms that pop up everywhere in mathematics, algebra, geometry, number theory, you name it.
So we're talking about something that's kind of woven into the very fabric of math itself.
Exactly. But what makes it even more intriguing is that quadratic forms aren't confined to some abstract mathematical realm. They have tangible applications in diverse fields.
Okay.
For instance, in physics, they're essential for modeling the trajectory of a projectile.
Wow.
And in cryptography, they're used to securely encode information. So A000075 might seem like this niche mathematical sequence.
Right.
But it's a window into a concept that has a surprising impact on our world.
That's a fantastic bridge between the theoretical and the practical.
Yeah.
Now, this sequence isn't just floating around in the OEIS all by itself.
Right.
It's got some pretty significant connections to other mathematical works, doesn't it?
You're absolutely right. It's referenced in Sloan's seminal works, both the Handbook of Integer Sequences and the Encyclopedia of Integer Sequences.
Oh, wow.
Which speaks volumes about its relevance in the field.
Yeah.
It's also linked to a paper by Shanks and Schmid titled Variations on a Theorem of Landau. Now, that paper delves deep into advanced number theory concepts.
Right.
But the fact that A00000075 is mentioned there tells us it's connected to some pretty complex and important mathematical ideas.
And we can't forget about the practical side of the OEIS.
Right.
It's not just a static list of numbers, is it?
Absolutely not. The entry for A00000075 even provides examples of code in PARI and Python that can generate the sequence.
Oh, wow.
This highlights how the OEIS is a dynamic resource for computation and exploration.
Yeah.
Researchers and math enthusiasts can use these code snippets to investigate the sequence, further test hypotheses, and maybe even discover new patterns.
Speaking of exploring further, A00000005 even points us toward another sequence in the OEIS, like a breadcrumb trail, inviting us to delve deeper.
Yes, it cross-references A000044A0.
Okay.
We won't dive into that one today.
Okay.
But it's a great example of how the OEIS fosters a spirit of exploration and interconnectedness.
Right.
You start with one sequence and end up down this rabbit hole of fascinating mathematical relationships.
It's amazing to think that a question as seemingly simple as how many positive integers less than or equal to 2 to the power of n can be expressed in a certain way can lead to so many intriguing connections.
It really highlights how even seemingly simple mathematical concepts can have these hidden depths and unexpected implications.
Yeah.
There's always more to uncover, more connections waiting to be made.
Now, before we move on, there's one more detail about A000000 size that I think is worth mentioning.
Yeah.
It's something that might trip people up if they're not familiar with the conventions of the OEIS.
You're talking about the offset, right?
Exactly. You'll notice that the sequence starts at N0.
Uh-huh.
This might seem a bit odd, but it's a common practice in the OEIS. It's like starting a race at the 0 meter mark instead of the 1 meter mark.
Oh.
It doesn't change the race itself, just how we count the steps along the way.
It's an important detail to keep in mind, especially when working with the formulas and code related to the sequence.
Yeah.
You need to make sure you're starting your count from the right place.
So it's more of a technical detail than a conceptual one,
Right.
but crucial nonetheless for accurate interpretation.
Precisely. It ensures consistency across the vast collection of sequences in the OEIS.
Okay, I think we've laid a solid foundation here.
Mm-hmm.
We've seen what A000005 is, how it connects to the broader concept of quadratic forms,
Right.
and even touched on its links to other mathematical works and the practical tools available in the OEIS.
It's a great reminder that even a single sequence can hold a wealth of information and open up doors to a whole network of interconnected mathematical ideas.
Absolutely. And with that in mind, let's transition to digging a bit deeper into some of those connections. What stands out to you as the most compelling aspect of A000075? Is it the link to quadratic forms, the references in significant mathematical works, or something else entirely?
For me, the most fascinating aspect is how this seemingly abstract sequence bridges the gap between pure mathematics and real-world applications.
Okay.
We often think of number theory as this esoteric field,
Right.
but A000075 vividly demonstrates that these concepts have practical implications, whether it's understanding the motion of objects or ensuring secure communication.
That's a great point. It challenges the misconception that math is just this theoretical pursuit disconnected from the real world. It shows that even a seemingly simple sequence like this can have profound implications for how we understand and interact with the world around us.
Exactly, and it highlights the importance of curiosity-driven research.
Right.
Who would have thought that a sequence counting numbers that can be expressed in a particular form would lead us to such profound insights?
It's a testament to the power of exploration and the interconnectedness of mathematical ideas.
Right.
Now, we talked about how A000075 points us to another sequence,
Yeah.
E00248,
Right.
without getting too bogged down in the specifics.
Yeah.
Can you give us a sense of what makes that connection so intriguing?
Well, both sequences delve into the representation of numbers using specific quadratic forms,
Okay.
while A000075 focuses on the form 2x sopels plus 3ya, A002480 explores a different form, x0 plus 6y0.
Okay.
By comparing and contrasting these sequences, we can gain a deeper understanding of the properties and relationships between different quadratic forms.
So it's like having two pieces of a puzzle that fit together to reveal a larger picture.
Precisely. And the beauty of the OEIS is that it provides this incredible platform for exploring those connections, for piecing together the puzzle of mathematical knowledge. It encourages us to think beyond individual sequences and to see how they relate to each other, forming this intricate web of mathematical relationships.
And that web extends beyond the OEIS itself. We mentioned earlier that A000005 is referenced in significant mathematical works,
Right.
including papers by renowned mathematicians like Sloan, Shanks, and Schmid. What does this tell us about the significance of this sequence within the broader field of mathematics?
It tells us that A000075 is not just a random curiosity. It's a concept that has captured the attention of some of the brightest minds in number theory.
Right.
The fact that it appears in these seminal works suggests that it plays a fundamental role in our understanding of certain mathematical principles.
It's like a key that unlocks a door to a deeper level of understanding.
Exactly. And it reminds us that mathematical discovery is an ongoing process. There are always new connections to be made, new insights to be gleaned, even from sequences that have been studied for years.
Speaking of ongoing discovery, I'm curious to know what you find most exciting about the field of integer sequences in general. What keeps you coming back to the OEIS and exploring these numerical patterns?
For me, it's the sense of wonder and the thrill of the unknown. Each sequence is like a mystery waiting to be unraveled.
Right.
You never know what you're going to find, what connections you're going to make, what surprising insights you're going to uncover. It's like exploring a vast, uncharted territory.
Wow.
And the OEIS is our map and compass.
I love that analogy. It really captures the spirit of adventure and discovery that permeates the study of integer sequences.
And it's not just about the individual sequences themselves. It's about the patterns, the relationships, the underlying structures that connect them.
Right.
It's about seeing the beauty and order in what might initially appear to be just a random collection of numbers.
It's like finding the hidden code that governs the universe.
Exactly.
Yeah.
And the OEIS gives us this incredible tool for deciphering that code, for understanding the language of mathematics.
Well, I think we've done a fantastic job of deciphering the code behind A00000075 today.
Yeah.
We've seen what it is, how it connects to the broader concept of quadratic forms, explored its links to other sequences and significant mathematical works,
Yeah.
and even delved into the practical applications of these seemingly abstract concepts.
It's been a fascinating journey, and I hope our listeners have gained a newfound appreciation for the beauty, complexity, and real-world relevance of integer sequences.
Absolutely. And before we wrap up, I want to leave our listeners with a challenge,
Okay.
something to ponder as they continue their own exploration of the OEIS.
Right.
We've seen how A00000075 connects to quadratic forms used in physics and cryptography.
Mm-hmm.
But what other fields might these concepts be applied to?
Yeah.
How might they be shaping the world around us in ways we haven't even considered?
That's a fantastic question. It's a reminder that there's always more to discover, more connections, to make more insights to glean from the vast and ever-expanding universe of integer sequences.
And on that note of endless possibilities,
Mm.
I think it's time we bring our deep dive into A00000075 to a close.
It's been a pleasure exploring this fascinating sequence with you.
The pleasure was all mine. And to our listeners, thank you for joining us on this mathematical adventure. Until next time, keep exploring, keep questioning, and keep discovering the wonders of the OEIS. It's amazing to think that just one sequence, A00000075, has given us so much to unpack.
It really is a testament to how much depth there is to explore within the OEIS.
And for those of you who are just joining us, we've been diving deep into the online Encyclopedia of Integer Sequences, focusing on sequence A00000075 and its fascinating connections to quadratic forms and real-world applications.
And the beauty of the OEIS is that it's freely accessible to anyone with an internet connection. You don't need to be a professional mathematician to appreciate the beauty and intrigue of these numerical patterns.
That's what makes this resource so powerful. It's a gateway to the world of mathematics for anyone who's curious enough to take the plunge.
So if you're feeling inspired, I encourage you to head over to the OEIS website and just start exploring.
Okay.
Pick a sequence that catches your eye, read the definition, look at the graph, check out the references, and see where it leads you. You never know what mathematical treasures you might uncover.
It's like embarking on a mathematical treasure hunt. And each sequence is a clue leading you to a deeper understanding of the universe of numbers.
And remember, the journey is just as important as the destination. Don't be afraid to get lost in the intricate web of mathematical connections. Embrace the challenge and enjoy the ride.
Well said. On that note of exploration and discovery, it's time for us to wrap up our deep dive into A00000075.
It's been a pleasure unraveling this fascinating sequence with you.
Thank you for joining us on this mathematical adventure. Until next time, keep your minds curious and happy exploring.